All right, welcome back. I wanted to work a couple examples on the uniform distribution, and here is question 3. It says a packing plant uses a 170-meter conveyor belt to move filled cans to the crating area. When a can falls off of the belt, it is equally likely to do so at any point along the route past the 20-meter point, where a series of guardrails ends. Let x be the distance in meters from the start of the belt to the point where the next can falls off. Assume that x has a uniform distribution and compute the probability that the can falls off at a point between 21 meters and 74 meters from the start of the belt. So I'm going to take a little snip here of this and show you how I would do this using Excel. So over here, copy this. So a couple of things that are interesting. We have a 170-meter conveyor belt, but the can's not going to fall off in the 20 meters at the start where we have the guardrails up. So really the length of the belt we need to consider is 170 minus 20 for when the thing can actually fall off. Because it would be like 0 right away for a bit. So if I try to draw a distribution, and I will here, I'm asking you to, so I will also. The way this would work, if something here, pretty ugly, right? But along here at 20, we could start falling off. And so it goes and ends at 170. And so our uniform distribution would go something like that. So we need to find the height here, and then we're looking for from 21 meters to 74, and I'm going to just do something like this. Obviously not to scale, but we're trying to find this area right here. That's the actual answer to our question. So a couple of things for the height. I'm going to grab the information that's important here. So our interval goes from 20, well, our belt, excuse me, our A and our B for our uniform distribution go from 20 to 170. And so we can find that distance covered there between them, how wide it is, by doing 120 minus, 170 minus 20, and that gets us the width. And then the height will be 1 over this guy right here. It works a little better if I put an equal sign in there. 1 divided by, let's see if it'll let me click the cell now. Okay, so this would probably be a little bit easier with the numbers here, but I just want to have the work shown so that you can see it. Now, I forgot to grab the one. Anyway, so now we need to find the width of this here. This is the width of our belt, our whole conveyor belt, but the probability that a can falls off somewhere between 21 and 54, I think it was 74, my bad, here. That's what we're looking for. And so it's going to be this same height here multiplied by this width of our actual interval there. So I need to find out how wide that area is that we are looking for specifically. And so I'm going to just do 74 minus 21. Again, 74 minus 21 tells us how wide this is. And so the area of it is going to be this width here multiplied by the height here. And so the probability then is this one times this one. And I'm just letting Excel do all the work. And we needed to round this to, I think it was 3 decimal places. So 0.353 is looking like my final answer here. 0.353. Okay, so a little bit of work there. Here we have another great one, a professor, just finding some more betweens. I want to go over a couple of these. It says the actual volumes of quart-sized jars of Hellmann's mayonnaise are uniformly distributed from 31.41 to 32.41 fluid ounces. Find the average volume of a quart-sized jar of Hellmann's in fluid ounces. Note there are 32 fluid ounces in a quart. And so these are multiple choice. But essentially here, this is a fancy question asking us to find the mean. So if I go here, paste it, maybe zoom in a little bit, maybe not. Oops. Okay. So we have an interval here, and it goes from 31.41 to 32.41. So I'm asking you to draw a picture, so I will too. 32.41, and you can see just kind of scribbling on here, not super concerned about the details or the drawing being to scale here. Anyway, but the average is the midpoint. It'll be this guy right here in the middle of our uniform distribution. So it takes a little bit longer here to draw than it does to do the work. So our beginning 31.41, our ending 32.41, our mean, this was mu, was equal to, we add these two up, the sum of our beginning and end, and we divide by 2 because it's essentially the midpoint. Now you might have noticed the interval was only 1 unit wide, and so half of that would be half of 1, so we can take the small side and add it. But if we didn't know here, we've got 31.91. Now there's another one of these where it asks us for the standard deviation, and the standard deviation is the square root of b minus a quantity squared divided by 12. And so I kind of need to find this width here. That's what b minus a is. If you don't remember the formula, it's here. Both of them, the mean and the standard deviation. So I'm going to just do this, but I'm going to kind of do it in steps so that it makes a little bit more sense to me. So I'll say b minus a is right here. Maybe not a great one because it's 1, and 1 squared is 1. So b minus a quantity, squared. And if I did this here and didn't know, I just take this guy, do a caret and a 2, and that squares it. Now I want to take this quantity and divide it by 12. And so b minus a quantity squared over 12 is going to be this value divided by 12. And then lastly, our standard deviation here, sigma, is the square root of this. And so I'll start typing, grab the square root function, close it up, and we would have our standard deviation. Just going back in here and add in a little bit of work. So again, a little bit with uniform distributions here. We had finding an interval, drawing a picture, finding a probability, and then doing a mean and a standard deviation. So I'll probably come back and do a percentile problem in the next one. Thanks for watching.